Okay, so let's look at the next one, which is x sine y plus cosine x equals y to the third. We're asked to find dy over dx. This clearly says what if I'm asked to find dy over dx? It clearly says that y must be a function of, this one tells us. Exactly. If I'm asked to find dy over dx, it's very clear that y is a function of x. So, let's work on this for a minute. How do we determine dy over dx? What do we have to do? How do we find dy over dx? Anyone? Implicit differentiation. There is no other way. So the left-hand side. Can anyone dictate? This is a product. First function, second function. Yes? Times? Perfect. Plus? Perfect. Careful. Very good. Plus, I should say minus, but that's okay. Very good. Equals. Very good. Very good. What happens now? Correct. So I will have to move this term to the other side and factor out dy over dx. So the first one is sine y minus sine x equals 3y minus x cosine y dy over dx. Is this clear? Yeah, but is the step clear? Oh, yes, of course. Thank you. Thank you. Is this clear? I move this term here and I factor out dy over dx. So I have sine y minus sine x, and then I factor out dy over dx, and I have 3y squared minus x cosine y. Now I divide by this, yes. dy over dx equals sine y minus sine x over 3y squared minus x cosine y, and this is the end of it. Is this okay? Can we move on to number 7 then? Yes? So then we have y equals tangent x raised to x squared. Let's work on this for 1 minute. There is no escaping now. I have to apply log. We can differentiate. We don't know how otherwise. Differentiate a function raised to another function. Can anyone dictate the first step? Okay, so natural log y equals
So you pull it 2 or you pull the x squared? Like
x squared.
Okay, then it's natural log tangent of x.
Good. And now
Um,
we have to differentiate both sides implicitly. So let's see what we get. 1 minute. I said 1 minute, but not talking for 1 minute. I want to see what you're doing. Can anyone give us the left-hand side for now?
1 over dy.
Very good. 1 over y times dy over dx. What about the right-hand side? Two x times natural log of tangent x plus
Squared.
x squared,
1 over tangent x.
1 over tangent x times,
Secant squared x.
that's it. It's not done because we have to solve for dy over dx. Doing what? Multiplying both sides by y. If you don't want to keep any fractions, you can change this into cotangent. And I'm going to do that. It doesn't matter, really. It really does not matter. So dy over dx equals, and y was tangent x raised to x squared. And this is 2x natural log applied to tangent x plus x squared cotangent x secant x squared x. And this is it. I changed this into cotangent. You don't have to. It's fine as 1 over tangent. Do we want to look at the cost function again, or number 8, or we move on to, yes? Okay. So the cost in dollars of producing x units is C of x, 1200 plus 12x minus 0.1 x squared and plus 0.0005 x cubed. Find the marginal cost function. So that will be C prime of x, which is 12 minus 0.2x plus 0.0015x squared. And this is the marginal cost. So what would be C prime of 200? Let's calculate it. And what would it represent? How much is it? We have an answer for C prime of 200? Okay, I'll determine it.
32.
Per unit?
Um,
Okay, what does it represent? Or what does it predict? It predicts the cost of the 201st item. Okay, compare your answer from part B with the cost of producing the 201st item. So cost of producing 201st item. How do I determine that? The exact cost. So what will that be? That equals
32.4015.
is C of 201, the exact cost of C of 200, the exact. This equals this difference, the exact change in cost. From producing 200 to producing 201. So let's calculate. The easiest thing to do is put the cost function in the graphing calculator and determine those two values. So that's what I recommend. So in y equals, I will put in 1200 minus plus 12x minus 0.1 x squared and plus 0.005. No, there is one more zero in there. X cubed. And then we go to second and table. We'll plug in 201. And I will plug in 200. So it's 3632.2005 to be exact, minus 3600. So the exact difference is 32 in cost. If we move up from producing 200 to producing 201, dollars per unit. Because it's 1 unit, actually. I just have to say dollars. I don't have to write per unit. But because it's just 1 unit. Any questions? Any questions? So the extra credits is the exact problem that we did together today at the beginning of the class for a different point, I think, or maybe the same. No, it's the same point. So we do have number 9 left. So we want to use differentials to estimate sine of 89 degrees. So what is that very important result that we've been using for a while with differentials and approximations? I think it's easy to remember if you pay attention to this. So f of x plus a little bit, or an error of x, or in x plus a little bit. This little bit can be positive or negative, of course, is approximately equal to f of x plus a little bit of y, which is dy. dy is a differential of y. But I have to write the definition, which is f prime of x dx. So if you remember this, you will be able to use it not just now for this test, but in general. Now I have to identify the function, I have to identify x, and I have to identify dy. I'm sorry, I meant dx. So what is the function that we are looking at? Very good. It is sine x. Perfect. What is x that we are looking at? 90 degrees indeed. Very good. And how much is dx? Perfect. Degrees. I don't want to forget this is the same with negative pi over 180. Because I'm not going to put negative 1 degree in any trig function. So it has to be changed into radians. Good. So knowing that, and knowing that the derivative of sine x is cosine x, then I can write what?
So it's sine x plus cosine x.
Right, but I want to use the definition.
Sine 90
Very good. Plus
cosine of 90
cosine of 90, awesome, times negative
pi over 180.
180. But how much is sine 90? Perfect. How much is cosine 90? So this is all 0. So let's check. Does it make sense? So we want to make sure that the mode is in degree. Yes, it is. So we want sine 89 and see how close it is to 1. Quite close. Yep. Okay, so now let's focus on other problems that you think we need to practice more. So let's choose anything you can think of, anything you would like to review of any type. If not, I will choose. Okay, can I choose then? Okay, 81 on page 266, in which we have a function h of x equals, say it again? Oh, yes, of course. Sorry. 81 on page 266. H of x equals f of g of sine 4x. We're asked to find h prime in terms of f prime and g prime. So the question is, find h prime. We're not given f and g, and we're told just find h prime in terms of f prime and g prime. Any suggestions? Any ideas here? Yes. So what do I write?
So it's prime of
G of sine 4x. Perfect. Times
g sine of 4 prime
of sine 4x,
times sine prime
which is
cosine
cosine 4x times,
4.
that's it. Any questions on this?
Just like run through that like quick again. And
But is it okay?
it's alright. But like not
Okay.
very, you know.
Let's do 104. Any questions? 104 on 267. Find dy if y is x to the third minus 2x squared plus 1 when x is 2 and dx is 0.2. So what are we asked to find now? Very good. And also evaluate it for the given values. So dy equals,
3x
yes,
minus 4x
yes,
times
yes,
times d y over dx.
no,
Yeah.
just dx. So remember dy is the differential of y and it's only f prime of x dx. Good. All I have to do is plug it in. So dy will be 3 multiplied by 4 minus 4 multiplied by 2 and everything multiplied by 0.2. So 12 minus 8 is 4 and 4 times 0.2 is 0.8. Any questions on this? Any questions?
So if you're solving for dx, is it f prime of x times dy?
So if you want to solve for dx, it will be dy over f prime.
dy.
But we're not really interested in that. Okay. Unless x is a function of time, then yes. And we had that situation before when when y and x were functions of time. So here's an example that you probably need for that problem, right? So when this is x and this is y and this is w, and they all are functions of time, then we have w equals x squared plus y squared. And when you differentiate, you have 2w dw over dt equals 2x dx over dt plus 2y dy over dt. So x can be a function, and sometimes x is a function. Good. We want, oh yeah, so 83. On page 266. At what point on the curve y equals natural log of x plus 4, everything raised to the second power, is the tangent horizontal? At what point is the tangent to this function horizontal? What do I have to do?
Find y prime.
Very good. I have to find y prime first. Awesome. Which is?
2 natural log of x plus 4 times 1 over x plus 4.
Awesome. 2 because the power of natural log is 2. 2 in front. Subtract 1 from the power. Times the inner function prime. Times this inner function prime, but it happens to be 1. Good. So we found the derivative. But we really want to find points at which the function has a horizontal tangent. So what do I have to do next? By horizontal tangent, I mean slope or derivative 0. Horizontal tangent means the slope is 0. So horizontal tangent means y prime equals 0. So then 2 natural log of x plus 4, everything divided by x plus 4, I change it into a fraction because this is all over 1, equals 0. When is a fraction 0? Only when the, very good, only when the numerator is 0 or you just cross multiply and you get the same thing. 2 natural log of x plus 4 equals 0. I will definitely divide by 2. That will not change anything. So natural log of x plus 4 is 0. So log applied to which number is 0, or we change this into an exponential equation. Or we ask ourselves, okay, I apply log to only one number to get 0. Which number would that be? Or I say the base raised to this number equals this number. Yes. Yes. So x plus 4 must be 1. Therefore, x must be good. Now the question was, at what point is the tangent horizontal? So let's say this is point P. I determined the x-coordinate. What do I do to find the entire point? In other words, to find the y-coordinate. Plug it in the function, right? So this must be the function evaluated -3. So -3 plus 4 is 1. Natural log of 1 is 0. 0 squared, 0. So then the given function has a horizontal tangent when x is -3 and y is 0. At the point P, -3, comma 0. Any questions? Yes, Tom, you had a question? Okay. Yes. Yes?
I do have a question.
Yes. Yes, the previous problem?
Yeah.
Okay. Okay. In the meantime, I'm looking for more anyway.
Oh, I found it.
Yes?
So for 104, the one that we just did up there, I was wondering where you get dx from. In that equation, when you do dy.
Yes.
you
So
find
this
the
is the
derivative of y.
This is the form. No, it's not the derivative of y. dy is not the derivative of y. The derivative of y is dy over dx. But we are not asked to find dy over dx. We're asked to find the differential of y, and this is the formula. The differential of y is f prime of x dx. We need this for the entire chapter 5. We need to understand what the differential of a function is when we get to integrals, because of the substitution rule and because of everything else we do with integrals. So do not confuse these two. Very important. This is y prime. dy is f prime of x dx. It's only the differential of y. Good. Next question. Anything else so far? Yes?
Can you do a question about from 310 is anything about linear approximation and difference?
Yes, let's take a look. Yes. We had that. Yeah, we just had that was 89, but yes, let's look at more. So you want 310?
The one with the triangle.
Yes. Did we look at the edge of a cube? No, we did not. Okay, let's look at problem 33. So please read it and see if that's what you had in mind. Okay, that's okay. The edge of a cube. So this is the cube. Okay, I'm going to just read for a moment. The edge of a cube was found to be 30 centimeters. So this is 30 centimeters with a possible error in measurement of 0.1. before I read on, I need to identify what 30 means, and I need to identify what 0.1 means. And then I can read on.
30 is x.
Very good.
0.1 is 3x.
Very good. Perfect. Thank you. Use differentials to estimate the maximum possible error, relative error, and percentage error in computing the volume of the cube and the surface area of the cube. So in part A, they want us to find what? dV and
Yes.
so they want in the volume and then the surface area. And in part B, they want ds. Perfect. But of course, they also want dV over V and the percentage, but this is the main idea for part A and part B, and we will determine all of them. Perfect. So in order to determine dV, what do I have to have?
The formula for volume.
The formula for the volume. Very good. So what is the formula for the volume of the cube? The volume. Area of the base times the height. Very good. So now we want to determine dV. So let's determine dV.
Yes.
Very good. So now I'm ready to plug in the numbers. So dV equals 3 multiplied by 30 squared and multiplied by 0.1. And you will give me the calculation, but tell me what is the measurement unit first?
Centimeters. Centimeters cubed.
Cubed, right? Because it's the error in the volume. 270? Yes? Okay. So now they also want the relative error. Remember, the relative error does not have a measurement unit because it's dV with respect to V. In other words, what is the percentage? How much error over the volume? So dV is 270. And the volume, I have to calculate the volume, which is 30 to the third power. How much? 0.01. And in percent, so no measurement unit because it's cubic centimeters over cubic centimeters. No measurement unit. So in percent, 1%. So this says this, that if there is an error in the measurement of the edge of the cube of 0.1, tiny 0.1 centimeter, then that will trigger a relative error in the volume of 1%. Or it will trigger 270 cubic centimeters as the differential in the error in the volume. So this is the relative error and this is the percent error. So now let's go to the surface area. So this was part A and this is part B. What is the surface area of a cube?
6x squared.
Very good, 6x squared. First we are asked to find ds.
That's
12x times dx. So then ds will be, I'll plug in the numbers, which they are 12 times 30 times 0.1. So this is 36. Measurement unit.
centimeters squared.
Very good. So now we're asked to find the relative error and the percent error. So this will be ds divided by s. We have ds, we just calculated 36, and we divide by s, which is 6 times 30 squared. How much is that?
0.0067. 0.67%.
So it's 0.67%, no measurement unit. So this is the relative error, and this is the percent error. Any questions? Should we do another linear approximation? Okay. So let's say f of x equals x to 3/4 and a equals 16. We want to find the linear approximation. I'm sorry, the linearization. The straight line, the linear function that approximates x to 3/4 near 16. Now, if you remember that important result that we just talked about, you should have no difficulties with the linear function that approximates the function anywhere, because it's the same thing. But this time is f of 16 plus f prime of 16 times x minus 16, which is the same thing. So let me go back for a second to that very important result for approximations. Here it is. Same, same, and now dx is x minus 16. Okay, so I have to find f prime. I have to plug in 16 in the function n f prime, and then find the linear function that approximates the function near 16, slightly to the left and slightly to the right of 16. So f of 16 will be, I'm going to change 16 into 2 to the 4th, everything to 3/4, because I can simplify and I get 8 without using the calculator. And then I have to find f prime. Is this okay so far? I changed 16 into 2 to the 4th, so I can copy the base, multiply the exponents. 4 over 1 times 3 over 4 is 3. 2 to the 3rd is 8. Is that okay? So now f prime of x is 3/4 x2, 3/4 minus 1, which is negative 1/4. Or if you want, 3 over 4, the 4th root of x. So f prime of 16 equals 3 over 4 and the 4th root of 16. But how much is the 4th root of 16? 2 times 4, so 3 over 8. Now I have all the information to plug it in. So can anyone dictate the linearization or the linear function that approximates f of x near 16 is?
8 bar
Yes?
3 times
X minus 16. I will distribute. So 3 over 8x minus. So when I multiply, I get 3 over 2. No, it's 3. Actually, I'm 3 times 2 and plus 8. Right? So 3 over 8 times 16 divided by 1, it's 2. So the line that approximates the given function near 16 will be 3 over 8x, and this is plus 2. Any questions? Any questions? Are we going to be ready for this test next Tuesday?
I hope so.
I hope you're going to say more than that, please. Any questions for me?